One last example of arc length, we have an object that moves with a position function of f of x equals 3/4 x to the 4/3 minus 3/8 x to the 2/3 plus 7. It leaves from the point 1 comma 59/8 and terminates its path at 227.515/8. X is the horizontal distance in feet from the origin, and f of x is the vertical distance. Find the length of the curve. All right, so basically, this is just a glorified example of an application for our arc length. Remembering that arc length is equal to integral from a to b square root of 1 plus f prime of x square dx. Now the limits of integration are 1 to 27, and the function is given right here. So let's find the derivative of that function. And so we're going to end up with 3/4 times 4/3 x to the 1/3 minus 3/8 times 2/3 x to the minus 1/3. Okay, or just cleaning up those fractions a little bit, that's going to be x to the 1/3 minus 1/4 x to the minus 1/3. All right, and what we have to do is we have to substitute it back into the formula. So we're going to square that out. Okay, so if we write this as a square, okay, we're just going to multiply it by itself. So that's going to be x to the 1/3 minus 1/4 x to the minus 1/3 times x to the 1/3 minus 1/4 x to the minus 1/3. All right, so just like we did in the previous example with the perfect square type, let's FOIL this out. So first, outer, inner, last. And if we do that, we get x to the 2/3 for the first term. Okay, so multiplying those two. And then we have x to the 1/3 times negative 1/4 x to the 1/3 x to the minus 1/3. We're going to get the exact same thing as the middle term. So negative 1/4 x to the 1/3, or x to the minus 1/3 x to the 1/3. And then finally, 1/16 x to the minus 2/3 power. All right, and notice what I did was I just multiplied the coefficients and then we add the exponents. Okay, so don't forget your rules of exponents. So this right here is just going to be x to the 0, which is just 1. So those just wipe out, and we're just left with negative 1/4 minus 1/4, which is minus 1/2. All right, this looks familiar from our previous problem. And so what we end up with is x to the 2/3 minus 1/2 plus 1/16 x to the minus 2/3. And remember, that's equal to our FOIL of x to the 1/3 minus 1/4 x to the minus 1/3 square. So keep that in mind, because that's going to be helpful when we plug it back into our arc length formula. Okay, limits of integration again, 1 to 27. So our length L is going to be equal to 1 to 27 square root of 1 plus what we just got, and the only thing that we can really do is just add the 1 and the negative 1/2. Right, so our arc length 1 to 27 square root of x to the 2/3 plus 1/2 plus 1/16 x to the minus 2/3. And I want you to notice that the radicand right here is precisely the same as what we got up top, except we have a minus and a plus here. And so remember, we can factor that. Okay, the only difference is that we're just going to change that into a plus. Of course, if you don't trust it, what you can do after you're done with this is you can just FOIL it back out, okay, and just see if you get back to the original radicand. Okay, so this is going to be equal to 1 to 27 square root of quantity x to the 1/3 plus 1/4 x to the minus 1/3. Okay, that's going to be squared and dx. Right? And fortunately for us, now we can just go ahead and eliminate the square and the square root. Right? And so what we're left with is integral from 1 to 27 of x to the 1/3 plus 1/4 x to the minus 1/3 dx. We're going to integrate. So this is going to turn into x to the 4/3 over 4/3 plus 1/4 x to the 2/3 over 2/3 from 1 to 27. Now cleaning this up just a little bit, okay, this is going to be 3/4 x to the 4/3 plus 3/8 x to the 2/3, 1 to 27. And now we're going to substitute 27, substitute 1. So we get 3/4 times 27 to the 4/3 power plus 3/8, 27 to the 2/3 power minus, and this one's easier, 1 to the 4/3 and then 3/8, 1 to the 2/3. All right, so just able to squeeze that in. All right. Now, at this point, we're going to try to compute. All right. So we know the cube root of 27 is 3. So this really just turns into 3 to the 4th, and this just turns into 3 squared. All right. And then over here, those are just ones. All right. So realistically, this is going to turn into 3/4 times 81 plus 3/8 times 9 minus 3/4 minus 3/8. All right, so now we're getting to the point where we just have to do some fractional computations. All right, this is going to be 243 over 4 plus 27 over 8 minus 3/4 minus 3/8. All right, so and of course you could just shove this in your calculator and probably be done with this. All right, but I don't have my calculator with me. I know this is going to be 240 over 4, just combining these two. And then this is going to be 24 over 8. So this actually works out pretty nicely because that's just going to turn into 60. And this is going to be 3. And by multivariable calculus methods, 60 plus 3 should be 63. All right. Now, let's go ahead and see if Wolfram Alpha likes that or if it doesn't like it, because 63 is a pretty accurate or a pretty nice answer. All right. So now remember, this is our function. All right. And if we go here, we go to Wolfram Alpha. All right. So what I did was I already plotted it just to go ahead and kind of save time. We already know what the graph looks like. And then we go down here and the length of the curve is 63. All right. So again, when you're doing your homework problems, use Wolfram Alpha to check. Okay. But when an examination, all the work right here is precisely what I would expect our students to be able to show. Okay. All right. So that's all for arc length. In the next section, we're going to take a look at a little bit easier topic, which is going to be the average value of